Welcome back. What I have here is another example of a confidence interval. Let me read this off the board. I'll step out of the way. It's about number of jobs. A sociologist found that in a random sample of 50 retired men, the average number of jobs they had during their lifetimes was 7.2. The population standard deviation is 2.1. First question, what is the best point estimate? Do you remember what that was? The best point estimate is, well, let's look at our numbers up here. What numbers are important? Sample size of 50, the average number of jobs, and the standard deviation. Those are the three important numbers right there. What is the best point estimate? The sample mean, 7.2. Okay, what is the margin of error? The margin of error comes from this equation right up there. Remember what part of it? Margin of error is this right here. Z alpha over 2 sigma over the square root of n. If we plug that in, 90%, 1.648. Excuse me, 1.645. I don't know what I'm thinking. Standard deviation, 2.1 over square root of 50. You type that in 1.645 times 2.1. Is that divided by square root of 50? 0.4885. Okay, how many decimals we got in this one decimal? So I'm going to round that to 0.49, 2 decimals. Now, one thing I want to point out, when you round, you always round this number up. Whatever it happens to be, wherever you pick, if you pick here, you make that a 9. If you picked, well, all these are big numbers you round up anyway. But if this were a 5-2 and you were going to go to 3, round that number, it'd still go to 6, even though that's a 2. Okay, find the 90% confidence interval. Well, you take your best point estimate, 7.2 plus or minus 0.49. So if we do that, 7.2 minus 0.49, 6.71, and 7.69. Okay, I'm going to keep this. I'm going to put it right here. And again, I want to change colors, so this will be easy to find in the future. 6.71, 7.69. Okay, so what I'm going to do is just like the last time, the last problem we did, is I am going to keep that, get rid of that, get rid of that, change this to a 98% confidence interval. And we're going to need 98 over here. And that number is 2.326. And don't worry about it. You'll get a table here very shortly where those numbers are on there. You just have to read them. Okay, so let's look at this. What is the margin of error for a 98% confidence interval? Well, our critical value for this is 2.326. Our standard deviation is 2.1 over the square root of 50. Type that in, see what you get. .6907. Okay, I'm going to round this to 2 digits like I did the other one. That means I got to round that number. That is bigger. I got to round up. So this actually is going to become 0.7. Most of you round that to 0.69. Most of you round that to 0.69. You should round it to 0.7. 0.69, that's bigger. Because we're always, if we round, we want the interval to get wider. We don't want the interval to get narrower. Okay, now find the confidence interval. 7.2 plus or minus 0.7. So that's going to be 6.5 to 7.9. Now, which of these is wider? Well, 6.5 is a smaller number than 6.71. 7.9 is a larger number than 7.69. This is clearly larger. Why is it larger? Because you got greater confidence and all the other numbers are the same. The only thing you change is the level of confidence. The larger the confidence interval, the larger the width of the interval will be. Now, what if we wanted to make our interval even more narrow? Suppose we wanted, and I'm going to pick a number different than both of these. I'm going to pick 95. I'm going to pick another question. What if we wanted to be 95% confident with a margin of error of, what were those margins of error? They were 0.7 was the big one. 0.7. So we want, well, let's do margin of error. Let's go with 0.4. How large does my sample need to be? Okay, how large does my sample need to be? Well, what do we have? We want to know how large the sample is. We're going to need to use that equation again. How large the sample do we need? N equals, we need the critical value for 95, 1.96. We need the standard deviation for this problem, 2.1. An error, 0.4 squared. See what we get here. 1.96 times 2.1. Okay, so there's the number I get, 105.8841. 105 is not big enough, so our answer is at least 106. Now, I have given you overall a couple of, or really 4. In this problem alone, I gave you 2 confidence intervals and finding how large sample size you need. The previous example had 2 problems and how large a sample size you need for a particular margin of error. That should be plenty of material for you to practice. So I'm going to go ahead and go to our next topic.